Jasmine Hempel. My team members are Alyssa Myers and Matt Warman, and this is our project, a comparison of active and passive attention-based tasks using the EEG waves with convolutional neural network. Our project compares active and passive attention-based tasks to each other during two states of attentiveness. These states are wide awake and tired. In order to collect data for analysis, we used an electroencephalogram, EEG for short, to record the data. We then built a 3D convolutional network to process the data and produce results. Our goals for this project were to first develop an adaptable 3D CNN and also to collect valuable EEG data that could be used in other studies. Our data collection process consisted of collecting data from 7 subjects. There were 6 data trials total. 3 of them were active attention trials, for example, playing a math game, and 3 were passive attention trials, like simply listening to music. All 6 trials were conducted once while the subject was wide awake and then again when the subject was tired. The picture to the left is an example of a subject conducting an active attention trial, and on the right, there is a visual representation of the data the EEG headset collected. Our 3D CNN model, as stated before, was created to process our data. This picture is a representation of the architecture of the model. We also created a GitHub repository that houses all the code for this 3D CNN and data used in this study. It can be found by using the link on the slide. For the experiments we conducted, our model processed different experiments on raw data, which is data straight from the EEG headset, and preprocessed data, which is data that has been filtered or processed to remove any noise, such as eye blinks, from the data. Our experiments included removing sensor channels from the headset, implementing Fourier transformation, which provides frequency analysis, and many other experiments. The images below are examples of sensor channel removal. The image on the left shows all 24 channels, and the image on the right shows what it looks like to use only 16 channels in our experiment. Once we processed all of our data through the 3D CNN, our results overall show that there is, in fact, a noticeable difference between active and passive tasks when alert versus tired. To be more specific, we found that the model is able to differentiate between a passive task when tired and a passive task when awake. It has a harder time doing this when active tasks are wide awake and tired. And with active tasks, the data looks similar when both tired and awake. To provide some percentages developed by the model, with raw data, we saw that the model is 4.64% more accurate when differentiating between passive sleepy versus active sleepy than it is when trying to differentiate between active tasks. With the validation data on the raw data, the model is 5.23% more accurate when differentiating between passive tasks versus active tasks. And then we also found that there was a 6.23% less prediction error when differentiating between the passive and active data. With the preprocessed data, on the training data, there was an 18.73% more accurate when differentiating between passive and active tasks. For the validation data, the model is 18.11% more accurate. And then there was a 13.43 less prediction error. So these are results. Thank you for watching.